Center of Excellence in Transportation, Electrification, and Energy Storage, Quebec, Canada. From July 2003 to May 2019, he worked at National University of Singapore. Over the past 20 years, he has conducted leading research on materials for energy storage, that is cathodes and anodes, supercapacitors and solid electrolytes, solar cells, electro and photocatalysis, including novel methods of synthesis and the evaluation of properties of materials and development of in situ techniques. Dr. Reddy has published around 200 papers in various international journals. He has obtained an H index of 65 with over 15,300 citations. These have recently placed him within the top 2% highly cited researchers in energy, that is ranking him 1,000 out of um, 1,86,500 researchers in 2020. Dr. Reddy is serving as an editorial advisory board member in Materials Research Bulletin and Journal of Energy Storage, that is published by Elsevier, as well as several open access journals, Materials, Energies and Molecules, MDPI, and the regional editor for Nanoscience and Nanotechnology Asia. Dr. Reddy has conducted several workshops related to functional materials and energy storage and conversion and delivery of 10 plenary, 22 keynote, 64 invited, and 18 contributory talks at various conferences. His research won many awards in national and international conferences. He has won an Outstanding Science Mentorship Award 2010-2018 and an Inspiring Research Mentor Award 2011 to 2019 from Singapore. He is also the winner of 2021 Battery Materials Award from the Electrochemical Society of India, Indian Institute of Sciences, ISC Bangalore. He is also an invited life member in the International Center for Diffraction Data, that is ICDDE USA. Without further ado, I would like to pass on the virtual stage to Professor Reddy.
Okay, thank you, Chairman. Before I would like to share my screen. Okay.
Sure, sir.
Yeah. Shall I? Yeah, I think now it's okay. Just 1 minute. Entire screen. So it is okay, sir. My slide is.
Yes, sir. It's good to go, sir.
Okay. So once again, so wait 1 minute. I'll put my. So I'll try to finish by 30 minutes since they've given me 30 minutes. So I'll make it. So afterwards, any talks is going on? Is the last talk today. So again, thank you very much, Chairman, especially for your
So
kind.
this is the last part here because you might be early morning in Canada, but here it is late 5 to 5:10.
Okay.
So
Okay.
we are about to finish the entire
Okay.
session for today.
Okay, I'll try to finish by 5:30 so that the 30
No,
minutes.
sure, sir. You can take your time. Thank you, sir.
Okay. Again, thank you very much, Chairman, for your kind invitation as well as introduction. So, and also thanks for the head of the department, Professor Ashish Kumar, and all conference team who are putting for the excellent event. So, what I am telling that although I'm a material research engineer, just at least some slides are very important for you people are working with a civil engineer. For example, importance of materials for what are the research people are talking about the green concrete or something like or some material characterizations are very useful for your especially research or some other areas. Sometimes people we are working with the area of autonomous vehicles. I think their importance of civil engineers, etc. Or in terms of the materials, the importance of civil engineering, etc. I'm going to discuss. So today I'm going to focus on especially maybe sometime what people call electric vehicles or, for example, batteries, some principles. I think that is very useful, and sometimes material characterization. I think that is very useful. Some people are doing the research. People are talking about the composite material, etc. Some techniques may be useful for your future research. And at the end, the material recycling again. If you talk about batteries recycling, different exactly same thing. If you talk about the building material recycling, again the terminology same. Only thing that the materials are different. So I'm coming from Quebec, Canada, where the French and English speaking colony here, especially. So our institute is working with hydroelectricity. So there you can see the importance of civil engineer. You can see the big dams. Again, if you want to be good construction engineering, again the importance of civil engineering as well as electrical and energy storage, etc. So again, you see that, for example, place like Canada here, we can see there is an extreme climate. For example, it will vary from -25 to 30. So there, I think we need the importance of the building, like insulation materials. Again, the importance of materials for the especially heating and cooling. For example, so that's why the importance of the materials play an important role in the this type of, especially if you're it is not like construction of building is different in India compared to here. Again, the people mostly they use wood, and then they in between they use some thermal insulation. I think that is very important, especially the temperature means like it's extreme cold. I think for that case, I think the insulation of the uh, insulation materials have play an important role. So I think these are my small outline. So again, I'm telling that when I was in Singapore, I trained a lot of materials. Students, students have been trained in the area of like science and engineering. I think some students, especially from junior college students, they can come. Later, they do some students, they can go to civil engineering, chemical engineering, or electrical engineering, depending on the interest. Idea is that just to motivate the researcher to do the research, and later they can use this type of, for example, XRD, microscopy. These techniques may be useful for you to go to civil engineering, example, do the research. I saw some talks in the previous presentation, the importance of XRD, scanning electron microscopy for the what they call material and composite characterization, etc. These are the small contributions I think students are able to present in the various national and international conferences, and some publications are listed here. So these are the some students that will present like us. I think they're able to present in national and international conferences, for example, science and engineering fair, and some students are able to present in the overseas, especially US and Japan, etc. I think these are the small contributions, especially from students from the NUS, as well as the few students from India and various part of the, like, for example, Iran and then UK, etc. visited our lab, and then they used the facility to do the battery material research. So these are the small collaboration we've been done within Singapore as well as India and different part of the world. So again, since although my talk is, I don't discuss too much details and the more specialized it. So since these are civil engineering, I'll try to just focus on one or two materials and later importance of the recycling, etc. So again, I think presently we know that energy, environment, and water and healthcare. I think these are the very hot areas. Again, if you talk about the environment, again, the importance of civil engineers. Again, we have to adapt depending on the climate, and we have to what they call them, we have to construct the building based on the materials. Again, the overall summary is that if you talk about any civil engineers or any battery engineer, I think they have to different way. People are talking about the gasoline vehicles are the, so that is way we can reduce by using batteries. For example, electric vehicles, I think we can reduce further with air pollution by using use of electric vehicles. So in terms of classification of materials, we broadly classified based on the material. For example, building material, wood, sand, concrete, granite, and then these are the materials. Again, sometimes people call as phase change materials, and sometimes some other applications. For example, temperature. I saw some few talks in some civil engineering. People are using sometimes phase change materials. For example, during that like just to see the temperature, depending on that one it is to attack. I think some in Australia, or New Zealand, some civil engineering workshops I've seen that some phase change material they use it for building to make sure that can use it for the especially temperature depending on the temperature how it's going to use this one. And also electronic material, this is also related to the, for example, silicon electronics or some engineering students are that will be very useful. And some explosive material, and engineering material is very important. For example, civil engineers, people are using the iron and steel and superalloys. especially depending on applications. We need lightweight, the importance of the material, again food and biometer, etc. Again, since we are the depending on other application based on physical properties, metal, semiconductor, insulator, and magnetic, especially optical means suppose people are talking about the smart windows. Again, the importance of materials for the smart applications. I think we need, especially the civil engineers. For them, people are. I think they want to be any building. They want to be. I think the materials, smart windows that will play an important role. Again, thermoelectric material, and then again today we are going to talk mainly in, for example, electric vehicles and smart grid materials for the electric vehicles and smart grid, etc. So, for example, you see since few slides the importance of the steel, as you can see that for civil engineering or if civil, the steel materials is very useful. For example, you want to construct very fancy buildings, or so you like to, especially for the transportation as well as different type of applications, or you would like to construct some fancy building, or sometimes people are talking about the composite materials, especially for example, mechanical engineers or people they can use the fiber reinforced composite for the aerospace applications. So another important area people are talking about the smart windows. Again, the importance of the there are all the things are very important once you go for more advanced research. Although civil engineers will not worry about how to prepare this material, still at the end it is nice for you to understand the how the importance of these materials. So again, people are talking about these smart windows. Again, these are the typical principle. They use some glass substrate and then they put some electrochromic mixture and we use the like positive negative. So the advantage of these smart windows. So for the especially for the expensive buildings, they use this type of the technology. And also another way is the thermoelectric material. Suppose for example you want the heating and cooling, so or sometimes so we can use this type of the materials, especially if you're talking about the biological samples, or for example laser cooling, etc. For example, so again the same technology maybe we use it for the say, different type of the material or whatever the way we want to do cooling and heating. So if you talk about this, for example, we know that they always talking about the green. Green means renewable technology. Again, there is a different type of the sources. Again, in summary, I can tell that in energy storage technology interdisciplinary area. Again, we have to work with the scientist in science background, chemistry, physics, and engineering. Again, civil engineering, material engineering, chemical and mechanical, and so again it means that it is very important all the people will work together. I'm telling some example how the importance of civil engineering. It is very useful. For example, if you talk about the autonomous vehicles, etc. Again, as a researcher, I think as depending on expertise, people do some prepare the material, for example, and try to characterize them depending on the available facilities, etc. So now if you talk about the importance of energy storage, suppose for example, if you talk about batteries, you can use it for you want to store the solar energy or wind energy, or you would like to run with electric vehicles. I think their batteries will play an important role. So and also idea is that using this, for example, renewable or battery materials, or this, I think we can reduce the pollutions, especially major cities. So again, I think that nowadays we are facing the problem of the environmental pollution. That's why people are looking for the alternative energy storage. So another area is the called autonomous vehicle. There are self-driving vehicles. Again, here it is artificial intelligence and light detection, lidar and radar sensing technology. The major benefits is that lowering the fuel consumptions as well as the development of the smart city, and also reduce the CO2 emission, and also we can reduce the traffic congestion, etc. And also people they predict we can predict 90% of the reduction in the vehicular crashes. So again, I'm telling that importance. For example, if you talk about the electric vehicles, again, in order to, I think the electrical vehicle construction is the one option. Either you can do the mechanical engineer, civil, example, other type of science and engineering we can work. Again, if you want to use run this vehicle, I think roads are very important, especially with the proper design with the proper things. Again, these are all software will work. Again, the importance of the electrical vehicle. 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 Aga engineers. For example, I think places like here in Canada, especially this during the snow importance of especially building. Accordingly, sometimes we can see shrinkage and then compare the things all. That's why. Uh, so what they call it, preparing concretes or the roads. Again, they, for example, uh, road construction again slightly different when compared to India and here, because here sometimes it has to adopt the climate condition. Example like extreme cold. So that's why. Uh, Depending on the regions, all civil engineers, you people are concentrating in a different way to construct either building or roads, etc. So now I think these are small opportunities. If you talk about something related to the engineering students, so now I think everybody is carrying this type of mobile phones. I think you people are carrying this type of the, for example, you talked about this type of the post cell that when you use it for your mobile phones or later you're running with electric, for example, laptops, you have some cylindrical cells, and later you can use this type of big like electric vehicles. There we can do this type of cylindrical cells, put it in a different type of pack. Idea here is that people want to use this type of the for this again here we need something like more safety. Those are all factors we take into consideration. For example, so depending on the energy, I think people can use a different type of packs. Or if you talk about the grid storage, although materials are same, we need little bit bigger size packs are needed. So for that case, we need little bit large scale manufacturing is needed. So if you talk about the smart way materials, suppose if you, again it has to adapt the climate condition. Again, it will vary. For example, places like Canada sometimes extreme climate, or places like India sometimes are in Middle East. Temperature it may go to very high temperature, so that's it is to the battery should be it has to, and long cycle life and high energy density and power density and capacity is also very important. And coulombic efficiency is almost like you have to get a good coulomb, I mean, almost 99% if you get it. Impedance resistance of the cell is very, very important. Always you get a lower resistance. And fast charging is very important. Sometimes people like filling gasoline or what are the petrol, so within 2 minutes 3 minutes you can do the charging. Is a little bit question mark. The main problem is that these are the solid state materials. There is a problem with the diffusion. That's why you have to wait for some time to almost like so that's why we cannot do it very fast. Charging and discharging is difficult. That's why anyway a lot of interesting things going on with the different part of the world. Idea here is that use this type of technology, make sure that we are able to use it for the especially for example fast charging is interesting thing is going on. So at the end we have to look for more safer material, low cost and toxicity. I think sustainability is very important. Recycling, I think this conference has been I think previous speaker or different presentation has been already nicely explained about the vertical research. Sustainability and recyclability is very important. If you talk about any concrete or any material, we cannot just, I think you to use the recycling, I think either in a different way. I think this is very important. So it applies to all, not only civil engineering, it is, applies to electronic engineering. For example, if you talk about electronic waste also, again you have to recycle. I think this is very important for especially in terms of the environmental pollutions or etc. I think we have to recycle it. That is very important. So suppose since I think this is very simple, I'd like you to make it a very simple presentation. So what is the principle of lithium batteries? It contains there is a positive cathode and negative electrode. Usually some metal oxides, either lithium containing oxides mixed with some binder, conducting binder and carbon. It is like similarly people are preparing some concrete. Exactly like once you need a major concrete, we need something. People are talking about some fibers. Exactly like binder. Binder is the things to make a material stick on the current collector. Without it is like this. For example, if people are working with ceramic composite, again they use some cases some green concrete or some fibers. They use that one. I think we can use this type of a material. And either anodes we can use, for example, uh, so we can use this material. For example, if you talk about the graphite, again the carbon fibers, again we can use some cases we can use this type of the anode material. And separator is the things with avoid the short circuit. There is a polymer sheet, so we can use that one for this applications. Suppose if you talk about lithium battery, sodium battery, potassium, again depending on that ion you can do. In case of lithium, we can use sometimes like silicon, carbon, also some LTO and metal oxides, and then some cases use graphite, etc. Why? Because the graphite is very like in it has a lot of natural resources. I think graphite we can use from graphite mines. And again, these are the things like charge means oxidation, or sometimes electrical engineer they call it state of charge, discharge reduction, and electrolytes we use either liquid, polymer, etc. And then these are the already I talked about the current collector for the anodes means this side, and then positive aluminum current collector people can use. So these are the importance of the 2019 Nobel Prize. As you see that almost lithium battery means earlier intercalation concept is developed in almost like 1972. So these early report. So they uh, followed by, for example, it took almost you can see that from the 19th it took a lot of time at the end time, and apart from that, so many important researchers has been contributed. For example, John Goodenough is a physicist and chemist. He's been, and also some other people from Japan. Also, some interestingly, Michel Armand, also one of the French chemists, also play an important role in the developing the rocking chair and polymer electrolyte. So that's why nowadays this technology is being used for the especially Sony. It's been commercialized. I think nowadays you see different type of car companies are using this type of materials, use it for the real applications. So these are the principle of batteries. It contains a cathode, anode, separator, and electrolyte. So during charge means lithium move from the cathode to anode, where the electron will pass to the external circuit. So during discharge again we'll go back to the virgin. That's why we call it the rechargeable battery. So it is a typical voltage versus current plot. So as you see that when you remove the lithium from the structures, we can see a plateau, for example, 3.9 volts, and this is the charge, and discharge is the reduction. That's why if you see the positive and negative current, it clearly indicates the rechargeable, called rechargeable batteries. The same thing if you plot voltage versus capacity, it's nothing but depending on the which type of material will get a plateau. For example, this type of the steep curves like this way you can see these are the voltage in the cell. For example, here 3.5, 3.4 volts or 4.2 volts. So typically you want to design new materials, or for example, people are always want to high energy densities. Always to look for the voltage should be higher is better, and you have to get extended plateau in the sense that this plateaus if you get it presently around, so now you have any new materials you look for almost 300 400 milliamp hour per gram. I think that will be very breakthrough discovery. So that's why we need a people are talking about the low cost or all this one we can do only people can extend these plateaus with the higher voltage and then higher capacities. So that is the basic terminology that made them to think as a researcher in a different way. So again, once you get high energy, high storage, again the people can use it. For example, as a civil engineer, you want to use as some, for example, grid storage. You need little bit low cost and all this one. So then you can use it for the different type of the applications. For example, if you talk about electric vehicles, again all the things, for example, with big storage devices, low cost, all this one factors plays an important role. So these are the different type of mechanisms. Since I don't have, this is not a specialized conference, I'm going to skip the details. Again, intercalation, deintercalation means here the any materials we have to see the volume very less volume variation. So it means that so during charge discharge cycle we have to give. That's why intercalation is a more popular. If you use silicon and some metal oxides, we depending on that different type of the mechanism. So it is very important always you to look for the anode should be you to look for the lower potential, cathode should be higher potentials, and material should be low atomic weight, and stability is very important. It won't react with you either cathode anode, and we have to get a good electronic conductivity. It is very important. So that's why. So you want to be fast charging. Material should be mixed ion conductors are very play an important role. So this is a typical summary based on lithium battery. That's why it is popular when compared to a lead acid, all these other type batteries, mainly due to the there is smaller, and also voltage is good as a consequence high energy density and lightweight. That's why, for example, space and lightweight applications, these materials are very play an important role. So again, we broadly the electrolytes, be either liquid-based electrolyte or polymer-based electrolyte. Again, liquid sometimes are flammable. That's why people, and conductivity is good. Whereas the polymers are really good, are flexible. Again, we can use this type of the materials. So in terms of separators, you can see that we can use either thickness. You can do less than, for example, these are very important criteria. So polymer should be nicely good mechanical strength. For example, if you talk about, it is almost applies to like a, and with nice wettability and puncture resistance, etc. Again, sometimes safety is a big issue. That's why recently people are concentrating about the replace the liquid electrolyte or some problem with electronic circuit, extensive things going on with use of the solid electrolyte with all mixed with all solids all together. Again, each technology having some limitations. For example, so thermal expansion coefficient has to match with both cathode and anode electrolyte, and good chemical stability in the sense that while sintering the materials, it won't react. This is very important. So anyway, these are the some sulfide based electrolyte as well as some oxides are there. So now I'm going to tell the importance of material processing and characterization techniques. I think some materials maybe use it for your civil engineering applications. Usual way is that depending on applications, what type of the properties, select accordingly, identify the material and check the structure composition. For example, for you people, mechanical properties are very important. So sometimes people call it a nano and submicron size material depending on which type of applications you want to use. So anyway, these are the importance of this. If you talk about the materials in terms of energy and environment applications. So I'm going to skip the little bit details since tonight. So there's the importance of material synthesis. For example, either you can do different types of chemical as a physical methods. Again, for example, people are the, for example, if you talk about the composite or applications, I think we need to press the thing either by hot pressing or additive manufacturing or spark plasma sintering. I think this is very important. People are working with mechanical engineering background, especially for civil engineering. Also, I think you people also will do sometimes what call preparing bricks. I think you have to press some like something like press. You don't use too high pressure still, especially I'm talking about the ceramic material, for example. Depending on application, for example, very expensive building, I think for them their cost is not a problem. I think they use some ceramic oxide or ceramic tile, or for example ceramic materials. I think there we need some lightweight and porous there. Then we use something like injection molding or hot press or something like photometallurgy techniques are already established as the techniques we are going to use. So again, these are the sometimes different type of the materials for energy storage and conversion, and these are the various characterization tools. Again, for example, as a civil engineers, you may use the XRD is very useful to see how the phases. For example, you have silica, and for example, you have some microscopy studies, or for example, some some studies are going to use. For example, sometimes people are talking about the, these are a little bit scanning electron microscopy is very useful to see the how the for example morphology of your bricks or etc. People can study by using these microscopy images. I think I'm going to skip the details about the surface area. For example, people are talking sometimes if it is nanomaterial, they have to see the small percentage of nanomaterial they can put it. So advantage is that the use of the high surface area materials to improve the mechanical properties, etc. That's why the people can use what they call green concrete, or so that application people are going to use. I think these are the various analytical. I think these are the importance of XRD. For example, you can try to put your sample somewhere here, any concrete, any cement, and then when X-ray beam is hits on this particular sample, diffraction occurs. In the sense that depending on, for example, you have if you have the amorphous materials or crystalline material, accordingly you can tell. For example, cement contains this amorphous cal or silica. So different type of phases we can see. So the use of the XRD, or sometimes people want to see some more details. You can do some transmission electron microscopy with sometimes nano aggregates, etc. These are all things only if it is useful, if you publish some papers in the specialized journals, etc. I can do. So I think I'm going to skip the little bit details on this. Yeah, I have another almost 4 minutes. So So important one cathode example, usually cathodes, we see this one. So usually this voltage is limited, and then we need a, so these are the promising type of the cathode material. These are the redox potential, and then cost factors, etc. So we can try to prepare either by simple tube furnace, we can try to by use of the carbon, and we can reduce the metal oxides to have either different lower oxidation state. And depending on that one, which are either sometimes use a carbon or graphene oxide, either you can pass with a different type of gases, which are the requirement, either oxides, nitrites, etc. So so again, I think one example, the typical example of the lithium containing cathodes, as you can see that these are the typical XRD patterns, clearly show that it almost like single phase materials. Once you do this one, you can take this battery material either by positive uh, composite materials and finally coat it on the copper or aluminum foil and roll it and punch the cell, and then we can get a again try the thing. This is a glove box if you want to research in the laboratory scale, where if you want to be the industry, I think they use a dry room. So for that case, almost kilogram the quantity, everything is automated, so everything it will do. So idea here is that once you know that coin cell fabrication, for example, you take a your coated electrode, put it there, and finally the cell is ready. You can do the either by charge discharge, for example, voltage versus capacity, or how long the battery is going to be die. In the sense that we wanted to see good battery, we have to get a almost like steady capacity. That's why we have to run for almost 2 to 3 months, depending on the battery system. As a typically good engineers, always if people want to get high energy densities, this potential should be go as higher is better. So see among all three materials, that's why we can this voltage is slightly higher. So that's why you can see sometimes depending on the different type of battery company, they may tell that energy density vary depending on the different type of companies. That's why, so each system, each chemistry, or whichever the material, depending on that one, your energy density is going to vary depending on which type of the technology they've used. Anyway, I'm going to skip the little bit details, and then anyway, sometimes we work some in novel materials. I'm going to skip a little bit more details about the how we can use this again. If you talk about the lithium versus sodium, somehow lower energy density because of the, we can get a lower voltage. So a little bit difficulties are there each technology. That's why still lithium is more popular because of slightly high energy density, and then technology has been a little bit more established. So now I'm going to quickly go through some examples. Sometimes what is the anode materials, etc. Again, I think graphite is more popular material. Again, the graphite. Again, graphene somehow is not cannot be used. Especially graphite is we can use it because since the average potential discharge potential, so lower limit that is very important. So again, I think people can use it for the this type of materials for different type of application. Again, I think I read something like graphene also. Recently, people have been reported as graphite, for example, concrete. So sometimes the bricks also they use this one as for the ci- civil engineering applications. So I'm going to skip a little bit details. For example, anyway, there's a lot of opportunity for the material researchers. So for the, either I can do different type of the things, either different type of the oxides. Since my time is going up, so what is my conclusion based on this type of the oxides? Again, there is a lot of scope for the as a engineer, materials engineer. Just you can look for the new materials and make sure that high energy. Once you get high energy, it is good batteries. I think that one you can use it for. So anyway, a lot of opportunities. For example, people talking about the civil engineers, titanium dioxide. People can use it for the coating, and then solar cells, etc. Again, depending on applications, we need something like a nano size materials. Again, the importance of the material researchers, always you have to look for high surface area. That is very important for the, depending on applications, which are things you have to take into consideration. Again, some materials have multifunctional applications. You can use it for DSSC, or sometimes people are talking about photo batteries, etc. So again, there are a lot of semiconductor. Again, some other areas, for example, sensors is very important. Sometimes people are working with automobile exhaust. I think importance of materials for depending on the sensors as well as glucose. I think these are the different type of the applications. So that's why importance of the materials. So since my time is going up, and then I'm going to discuss more details on this about the different type of synthesis, etc. So what I'm going to tell that, suppose for example, people are talking about the from fiber again, the either by taking natural fiber like sisal, or you can create by using the electrospinning instrument. You can use it for to prepare some polymer fiber or different type of fibers, etc. I can do. So, so what I'm going to tell, so anyways, I think sometime people, I'll skip the details about the green story. Just one last slide, the importance of the, for example, so materials play an important role. People are talking about, for example, nowadays purify oxygen. We need some high surface area materials. That's why, and also it has to, for example, ammonia or any nitrogen containing gases is to observe for. That's why we need some high surface pore size is very important. That's why people this technology, I think people are using for example COV or pure oxygen you want to prepare. I think they purge with oxygen gas to the catalyst. I think these are importance of materials for separation, recovery and recycling. So that's why, so it is suppose people want to use it for the large scale application. So I'm going to skip a little bit and then some explosion also will occur. So I think one last word I'm telling that any research or any materials want to material recycling is very important. If you talk about lithium batteries, also same story. You have to recycle this one. It should be less expensive, and it still is difficult because the problem is these materials are very and then global warming. That's why I have to dispose them in a properly, in the sense that either you direct and hydro and pyrometallurgy approaches. So this is a way usually you can do discharge, dismantling and pre-treatment. Again, uh, pyrometallurgy approach seems to be good because we don't need any water again. So again, this technology I think already demonstrated with big industries. I think it is going on. So I think I'm going to skip a little bit. I think these are the very important. These are my conclusions. Instead of taking conclusions, I'm going to take a question and answer. Okay, thank you very much, sir. Okay, since I'm last presenter, so that I don't want to. So sorry for already have taken some 4 minutes. Okay, thank you very much.
Thank you so much. Thank you so much. That was an interesting and a very great learning presentation. The thing is that because as civil engineers, we do come across situations where we need to characterize our leachate, where we have liquid samples, mainly in geoenvironmental engineering. So, and plus you talk about semiconductors, and it is gradually getting its way into environmental engineering also for purification of drinking water and rectification of sewage water. So it has been a very insightful presentation, and I know because of the time constraints you are not able to elaborate over it, but still I think it was definitely a big takeaway for all the attendees. I would like to take up the questions. If there are any questions, you could please put in the chat box. Uh, I think there is no question, but sir, I
No,
can.
there is
I
one question.
yes, sir.
Professor Reddy, let us say in civil engineering, we try to reduce the permeability always. We are more concerned with the more dense material or less permeable materials. Which are the newly available ways or the materials which I can use for making my soil more impermeable? Normally I am doing by compacting it heavily. So if I don't want to compact it, are there some materials or some composition which can help me to make my strata more impermeable, or it give more strength to me?
Sorry, the very good question. I think Professor Ashok Kumar has been raised a very good question. In fact, I attended few civil engineering talks. In fact, we can know the ceramic materials we can use. The problem is what based on the, I know that civil engineers people see the cost. If you buy any material, the cost is very high, and so people want to pay tons of the quantity. If it is that the cost is a major criteria. I think a lot of examples are there. So, for example, sometimes people they use some fiber, carbon fiber. They use it again. Although we can tell is academic research, see, at the end people wants to be, some interesting things going on. So for example, like expensive $1 million building, I think they don't worry about the cost. If you talk about overall the cost, I think there's a major, since we a lot of ceramic few materials are there, very lightweight and then very compacting. People can, again I told you that I talked about very expensive. For example, maybe you need some injection molding there, you can apply with very pressure, and then you fire it and we can get lightweight, and these are the things again based on the research is fine. I'm talking about the, if you go for practical applications, people think about how they cost. Those are a little bit viability issues also, that telling, yeah.
Thank you, Reddy sir.
And people have been raised one more question is magnification with SCM test are so it is very important. So I didn't talk about this one. Sometimes people are talking about nano and then you get to nano. So most of the ceramic like since you people are working composite, my suggestion is that you try to give something like a 10 micrometer bigger large scale, and then if you really want to explain saying that my ceramic composite is like really good, or I prepared some composite, then there is nicely particles, or for example silica particle is nicely attaching, then you can increase the magnification. You can tell that I've shown some 10 micrometers 10 micron size, or depend larger magnification, and then later you can, that is the way to usually researcher people can do. And also people are doing the best method technique to quantify the compounds. Okay, so it's very important. According to me, the amorphous nature best way is that we have. I didn't discuss more details since there is a top X-ray diffraction is one of the useful tools. And there, for example, in a cement, there is a percentage of amorphous like the best way is that you see what type of phases are there. For example, so then the cement it is not a single phase. It contains like, for example, calcium. So different type of phases we can see by using, you can tell okay this much percentage of phases. I think with X-ray is very useful. There is called as topaz, and a lot of commercial software is available. Best way, since you are civil engineer, I know it's a little bit difficult, your background is different, still best way you interact with some material engineers. I think this technology is very simple. Only you tell them I have seen this type of compounds, and they can put some database, automatically it will tell, and then easier for you. Once you're familiar with the software, I think later you can play it is very simple. In fact, if anybody want more information based on the XR itself, I think more specialized talks I can spend more focus on civil engineering example and how to analyze. Since the time is limited, I didn't discuss much on that one. I think that is very important.
So there's one more.
The people are asking about what is the rationale behind the conducting materials make the composite waste. Composite make that waste such as super. Okay, so what is the rationale? So it is very important. So what my suggestion is that food waste such as food waste. So again, it is a little bit different. For example, civil engineering, I think you will not bothered about conductivity. So for example, especially for this, if you talk about supercapacitor, again, for example, I think if you want to prepare a carbon, you can take a naturally occurring, for example, leaves or anything, you burn it by using the black color ash, you can use it to study supercapacitor. So another way is that conductivity is very important. Why? The reason is that suppose, for example, any ions has to move fast or go movement. I think conductivity is very important. The particle to particle contact. That's why people they use some amorphous carbon or sometimes carbon fiber. So that way people can use it. Okay. Or if we talk about metal oxide, don't use some insulating materials. So it will be difficult. That is the way. So that's why as a research engineers, depending on that one. For example, ceramic material. For example, tiles. I think there we need something like porous, and also sometimes good mechanical strength. So that's why depending on the which area you're working. Okay.
So I have one question. Let us say in civil engineering, we mainly have liquid samples. So what is the
Okay.
best characterization technique for liquid samples?
Okay. So my suggestion is that liquid sample, which one you're looking for, density or what type of things? Yeah. Anyway, you can use
Mainly
optical.
looking for physical and chemical characterization or microscopic characterization for, let us
Okay.
say, heavy metal detection and all.
Okay. Usually, I didn't. That's why one example is heavy metals. Because atomic absorption spectroscopy. That is very already known the technique. You can tell which type of metals are there. That is the best way to tell. So sometimes I know that that is the best way to do the chemical, what they call chemical analysis. Another way is that something like titration techniques, just to dissolve in a particular thing, you do it. The old technique, I think that is also possible. You can do it your own lab, and you can do some titration. You can take a burette, and then you can for example, that way also you can do. So best way is that the color ICP means induced plasma, like atomic absorption spectroscopy. That is very useful for you. Just to take that one, what they will do is that take whatever the material, just to dissolve it with HF or particular acid, and they can use the solution, pass into the atomic absorption. So there you can tell depending on which type of elements are there, automatically it will tell. Okay. So another way is that so you dry the what are the liquid types. If it is solids are dry, that one all, for example, so water everything, and you can use the crush it. You can do with X-ray. It will tell the information about the what type of phases and yeah.
Okay, sir. So, one last question. So, you were talking about rechargeable batteries.
Yeah.
Sir, whenever we are fabricating or designing of rechargeable batteries, do we keep in mind the disposition concern about it, like how will they be disposed? Because as we see it from a civil engineering point of view, when these batteries are disposed in landfills, they have problem of degradation. So is there any norm that which is followed, or what type of method can we use for decomposing batteries?
Okay, so I think quickly have gone through last slide. I think usually land filling it is not allowed because you know that there contain cobalt, and then because it's very toxic, and again environmentally, that's why it is not strictly, because now it's very small. Reality is future. If you too many electric vehicles, I think they will not allow. They is not good also. That's why what people they use that they have to take a batteries, dismantle it, and recover it, and recycle it. Because the problem, if you go for big electric EV vehicles, I think their material is very high. We have to scrap it, and we have to and then they can use by either by direct leaching you can do, or leaching technique like hydrothermal approach. Another one is the pyrometallurgy. Just you take that one, mix with some carbon, and then they heat it, and then recover the material. That is simple metallurgy approach. That is the old techniques people have been. Only problem what I noticed is the recovery. The main issue is the cost. That's why some mainly lacking is the cost. That's why what people are thinking that either government initiatives, or whatever they sell the battery pack, the cost of the things also. Since now we don't have any options, since we know the COVID-19, we are facing a problem almost years together lockdown. That's why future people will not be bothered about cost, and they worry about the environmental issues. That's why sometimes we have to closely, you have to change your like a mentality. I think you have to spend some like money in other way lesser, and this way still although cost is higher, I think people are going to. So now that thing slowly you have to adapt. So I think if you don't take care of environment, so again we may get some other type of like this type of almost like 2 to 3 years is a little bit catastrophe for throughout the world. Not only all the people, we are facing the problem. Again, that's why importance of you civil engineer. For example, Singapore, I was there, and I know that the construction of a building is slightly different when compared to engineers, like especially. So there they will not use the curing, or sometimes what they call as a 3D printed. I saw some technology about the 3D printed. Anyway, the reality is that, like, anyway, a lot of interesting things is going on. For example, same thing you people, for example, olden times. So you see that if you want to construct a big bridges, you used to do. Now everything is automated blocks. You can prepare and fill it. There's a lot, again, all the technology is a lot of interesting things going on. I think that is mainly due to materials and then technology. uh, and also, I saw some reports. I think regarding Professor Ashok, I saw some material they use it for something like uh, I think some plasticizer. I think they will sell and to make a good mechanical strength. Again, cost may be higher. So I think these are all important things. Again, I think they put it different type of the things they're using for especially the anyway, in fact, all the people you are familiar, so how they call Greek, what they call green concrete and green
Ye-
cement. interesting things, the words I've seen. Okay, thank you.
Thank you so much, sir. Thank you for taking up all the questions and discussing them so elaborately. It was a great session and it was very insightful. And I am honored that you delivered your keynote to ICCME 2021. And thank you for the wonderful session, sir.
Okay, sir. Thank you very much, Ashok Kumar Gupta and Saurav and all the people. And thanks for your time. I know it is almost 6 o'clock for you people. Okay, stay safe and then okay, good health, sir. Thank you. Thank you to all and
Thank
thank
you
you for
so much. Thank you so much for giving your kind time.
Okay, sir. Thank you very much, sir. Thank you, sir.
Thank you, sir.
Okay, thank you, sir.
Thank you, sir. With this, we come to the end of an eventful day. Though the first day of ICCME 2021 has come to an end, we all look forward with more excitement and more enthusiasm to the upcoming day 2 of ICCME 2021. I thank you all for being so active participants, patient listeners, and curious learners. As said by Dr. B.R. Ambedkar, cultivation of mind should be the ultimate aim of human existence. With this thought, I would like to end the day 1 of ICCME and eagerly wait to meeting you all tomorrow on the 4th of June 2021, that is the day 2 of ICCME. With this, I thank you all. Have a great night, stay safe and stay healthy. Thank you.
Thank you very much, sir.
Thank you, Dr. Saurabh, for
Thank you,
the
sir.
nice conduct of the